Next, here it is 3 or over. That is the potential energy on the surface of Earth and potential energy at height and change of potential energy. Now we are coming to this next formula, kinetic energy. Kinetic energy of a satellite, which is revolving very close to the surface of Earth. So, which is revolving in orbit very close to the surface of Earth. In that case, kinetic energy can be taken 1 by 2 m v naught square is here. So, 1 by 2 m v naught square is here. So, in this case, it is 1 by 2 m is there, and v naught square means square root of that is gm by r, because already we know v is equal to square root of gm by r, and that can be replaced by gr. So, now it is whole square is there, and that becomes capital G, capital M, small m by 2r is that kinetic energy. Kinetic energy is always positive. So, kinetic energy is always positive. So, that is why capital G, capital M, small m by 2r is here. Next, fifth one is a total energy here. So, in this case, total energy is nothing but here also, here we are giving that energies of a satellite which are revolving very close to the surface of Earth. So, that is why in case of this total energy is equal to Pe plus Ke. Very close to the surface of Earth means that is H is neglected. So, in this case, Pe plus Ke means Pe already we know that is a minus gmm by r. So, minus capital G, capital M, small m by r is here, and it is G, capital M, small m by 2r is here. So, it will be capital G, capital M, small m by 2r is there. So, that is a minus 2r is here. So, this can be taken 1 by 2 minus 1. So, that is why it is a minus 1 by 2. Now, here that is nothing but a minus K. Total energy is equal to minus K. So far, regarding that energies of a satellite, we could complete 5 formulae. The first one is, it is on the surface of Earth, and this is at a height, and this is a delta PE. Delta PE means that is the final potential energy minus initial potential energy, minus gmm by r plus h, and minus of a minus, that becomes gmm by r, and delta PE is equal to gmm by of 1 by r minus 1 by r plus h. And thereafter we can transform this formula in terms of the mg. So, this can be taken delta PE is equal to gmm and r of r plus h minus r, that becomes h only, and g is equal to gm by r square. So, gr square can be replaced here, and thereafter it becomes r will be cancelled. Now, r will be cancelled. So, it is mgrh. Next after that by r plus h is there. Now, that also can be taken mgr by h plus r means, suppose mgrh is equal to mgrh by r plus h. Suppose if r is taken the denominator, that becomes mgh by 1 plus h by r. mgh by 1 plus h by r. This also can be taken. If r is taken here, then 1 plus h by r will come. Next after that, it is the fourth one is the kinetic energy. Kinetic energy means it is the kinetic energy of a satellite which is rotating, which is revolving in a orbit closer to the surface of Earth. That's meaning is h we are neglecting. In that case, that is 1 by 2 m v naught square is there, we are getting this one. Kinetic energy is always positive, and the total energy. Total energy is Pe plus Ke, and the sum of that becomes minus gm by 2r. That minus sign indicates always that satellite is bounded to the center of Earth. It is attracted towards the center of Earth. So, that's why that minus sign is coming. So, minus Ke is here. And thereafter, the last one is that is binding energy of a satellite. Now, binding energy of a satellite means, suppose in an orbit closer to the surface of Earth, satellite is rotating. In that case, its total energy is taken as the minus gmm by 2r. Minus gmm by 2r is already there. And if you supply the same amount of energy, then automatically this satellite escapes into the infinity. So, that's why if you supply the same amount of energy in opposite direction, that's why it supplies into that, it escapes into that infinity. That's why according to that principle of conservation of energy, what we have to take, that is the TE in orbit and the next one is here it is TE at infinity. T in orbit means here TE orbit plus binding energy. Binding energy is equal to TE at infinity. So just like on the surface of earth and to the infinity we have compared, and here it is a kinetic energy plus a potential energy like this, and here it is taken, and already this is total energy is there, total energy of that orbit is there, and we have supplied some binding energy. In that case the total energy at infinity, so now it is binding energy that becomes already we know it is a minus gmm by 2r, minus gmm by 2r and plus BE is equal to 0. Total energy of that satellite at infinity is 0, and BE is equal to GMM by 2R is there. Its meaning is if you are supplying the same amount of energy, then that satellite which is in the attractive field of that Earth's gravitational field, and that will escape from that orbit. So you have to apply this much of GMM by 2R, this much of energy is required, and for that. So once again I tell you, so first of all these energies are, now first one is here potential energy on the surface of Earth, and it is a minus GMM by R. Suppose if at all the body is taken to height and minus GMM by R plus H, and delta PE also taken, and here in these cases we have not taken that velocity, here we have taken the position to position only, and it is total delta PE we have taken, and thereafter kinetic energy, now we are coming to that velocity. So kinetic energy means that a particular orbit root of gm by r whole square, gm by 2r is there, and thereafter total energy in that orbit which is closer to the surface of Earth, and this becomes, and thereafter if at all it is rotating closer to the surface of Earth in a particular orbit, then it possesses this much of energy. If you supply the same amount of energy, if you supply that same amount of energy to that satellite, then it will be free from that orbit. Then it can be free from that gravitational pull of Earth. So if you supply the same amount of energy to that orbit, then what is that amount of energy? That will be equal to opposite to that of BE is equal to, that is a minus TE. So it will be BE is equal to GMM by 2R. So now, so far we could complete two phases, these two phases of this gravitation. So gravitation, as I already told you, in the first phase what we have taken, that is intensity of gravitation, inverse square law of gravitation. So I write all those formulae what are coming in this gravitation. So first it is F is equal to capital G m1 m2 by d square is there, and the second one is, here it is intensity of gravitational field G m by r square, and the third one is the distance from that smaller mass, the distance from that smaller mass where that resultant intensity of gravitational field is 0, x is equal to d by root of m2 by m1 plus 1 only, it cannot be minus 1. Next, fourth one is variations of a small g. Variations of a small g means here what you have to take altitude, and for that altitude that formula is gh by g is equal to r by r plus h whole square is there. And here fifth one, next it is the gh is equal to, if h less than if h less than capital R, if h less than capital R, gh is equal to g of 1 minus 2h by r is there. And similarly, if h less than capital R, what is a percentage decrease in small g? And for that we have to take a delta g by g into 100 is equal to percentage decrease in small g is minus 2h by r. So you need not take that minus. So 2h by r into 100. 2h by r into 100, that is a percentage decrease in small g when the body is taken to smaller heights only. And thereafter it is sixth formula, when the body is taken to depth, in that case, that is a sixth formula is gd is equal to, that is a small g into 1 minus a d by r is there. And percentage decrease in small g when body is taken to smaller depth only. In that case the formula becomes, it is a delta g by g into 100, delta g by g into 100, that becomes that is equal to d by r into 100, d by r into 100. And thereafter now it is latitude effect, and for that we have the formula g phi is equal to small g minus r omega square cos square phi. So, and we have the two cases, that is phi is equal to 0 degrees, that is a possibility at equator, and again at poles, g phi is equal to small g minus r omega square cos square phi. All this is the first phase. In the second phase, when coming to this planetary motion, Kepler's laws, and for that Kepler's laws, only the two formula are coming, that is r square omega. So, it is 1 by 2 r square omega, aerial velocity is constant. Next one is t square proportional to r cube is here. That is the law of time periods, t square proportional to r cube, and thereafter orbital velocity, and thereafter gravitational potential V is equal to minus gm by r, and here it is next formula gravitational potential energy. Next one is escape velocity, and again the GSS. So regarding that concept is the GSS is there, and thereafter next one is if body is positioned with a velocity nve, and what is the velocity on reaching that infinity. So that is also next one. Here it is energies of a satellite. Energies of a satellite on surface at a height, and again kinetic energy delta PE is there, and again kinetic energy of a satellite very close to the surface of Earth, and total energy, and the last one is binding energy. Now gravitation theory, based on all these formulae we can solve the problems in next class.